Hello guys, welcome to another video, and in this video we'll discuss about equivalent lateral force method. It is one of the linear static analysis procedure, and in this video we'll discuss how we can calculate seismic base shear and lateral design force at different floors of a building by using IS code. We'll be using IS 1893 2002. Okay, and this is one of the linear static analysis procedure, and this is mostly used for low-rise structures and when dynamic analysis is not required. We have to carry dynamic analysis under these two conditions, and if these are not met, then only equivalent lateral force method will be enough for the design of structures. To calculate the design base shear, we have to find out horizontal acceleration and seismic weight of the building. The design horizontal seismic coefficient can be find out by using this expression, where Z is the zone factor that can be calculated using this table 2 of the code, and based on where the structure is located, we can find out the value of Z. I is the importance factor, and we can use this table number 6 for its calculation, and we have to use value of 1.5 for important structures like hospitals, schools, community halls like cinemas, and for other ordinary structures we have to use the value of 1 as importance factor. The value of R, which is response reduction factor, can be find out by using table 7, and based on the type of building we can use the value of response reduction factor. Mostly this factor is carried out to account for nonlinearity of the structures. The value of spectral acceleration coefficient can be find out by using the graph given in the IS code, and before that we have to find the time period of building by using this expression. By using one of the expression based on what type of building we are dealing with, we can find out the time period of the building. After that we have to determine the type of soil where the building will be constructed, and based on those two parameters we can find out the value of spectral acceleration coefficient, which is SA by Z. After that we can easily calculate the value of horizontal acceleration. And now we have to calculate the value of seismic weight of the building, and to calculate that, let us consider a simple 3-story building, and to find the seismic weight of the structure in each floor we have to consider like this. Okay, so for first story the dead load will be between these two height level. Dead load includes different slabs, beams, columns, and to calculate the seismic weight of each floor we have to consider some percentage of live load at each story. To find that we have to use another table, and for up to or including 3 kilonewton per meter square of live load we have to use 25%, and for above 3.0 kilonewton per meter square we have to use 50% of live load. For example, to calculate for seismic weight of first story we have to find out all the dead loads at that level, between these two heights. This is the second story and this is the third. Okay. Okay. And after calculating dead load, we have to, if the live load is less than 3 or equal to 3, then we have to calculate only 0.25. And 0.25 times the live load into the area of that floor. By that we can calculate the seismic weight of that floor. Okay. After calculating the seismic weight of each floor, and for the roof we should neglect the live load, and it will be like, it will be 0 for the roof. And during seismic activities we consider that there will be no live load at that level. After finding seismic weight of each, then we add up all those values to get the total seismic weight of the building. That is the total seismic weight of the building. Okay. And as we have already find out the value of horizontal acceleration, we can easily find the base shear. Okay. After finding the base shear, we can calculate lateral force at each story by using this expression. Okay. The lateral load at each level can be calculated using this formula. If we are calculating the base shear of second story, then we have to take the total height from plinth level as HI, and WI will be the value of seismic weight at second story. Then PB is the total base shear at the bottom of the building that we have calculated using a previous formula. By this we can calculate the total lateral load at each floor level, and we can easily design structures for the seismic load using static analysis procedure. This much for this video, and in the next video we'll discuss about how we can apply lateral load method to design structures in SAP 2000. Thank you for watching.